Brendan for the commercial, for the introduction. So my name is William Koo. I'm part of CASPA Board of Directors, and I'm your host this afternoon. As we all know, October can be a pretty scary month. No, I'm not talking about Halloween. I'm talking about stock market, the trade war with China, and yes, Michael, the hurricane. But may I propose this? For the next couple of hours, let's leave all the scary stuff outside the room. Here at CASPA, we don't have any tricks, but we have plenty of treats. Specifically, we have more than a dozen. Let me repeat that. We have more than a dozen very well-known speakers here in this room to share with us. They're going to tell us how to accelerate artificial intelligence and machine learning in the next couple of hours. So, without further ado, I'd like to bring up our first speaker today, Dr. Ziya Ma. Ziya is the Vice President in the Software Service Group and Director of Open Source Data Analytics Technologies at Intel Corporation. She's responsible for optimizing big data solutions on the Intel architecture platform, leading open source efforts in the Apache community, and bringing about optimal data analytics experiences for Intel customers. At the 2018 Global Women Economic Forum, Ziya was honored as Women of the Decade in Data and Analytics. She's also a co-founder of the Women in Big Data Forum. Ziya has received her PhD and MS in Computer Science Engineering from Arizona State University. So ladies and gentlemen, please help me to welcome Ziya Ma.
Okay, great. Good afternoon.
Good afternoon.
So we're in a data-centric world. 90% of the data in our human history was generated in the past few years. The data itself is not interesting, while the business insights derived from the data give us the competitive advantage, drive digital transformation, and push business differentiation. Deriving business insights from the massive amount of data requires modern data center infrastructure so that we can store data, we can process all kinds of data, we can move data faster. We need to have access to high-performance computing, high-throughput storage, and advanced networking services. We're observing a few exciting trends for the data-centric world. First, data is shifting from big data to fast data for real-time insights. And second, AI and big data are getting more closely integrated than ever for solving much more complex problems. So in the rest of the presentation, I'm going to expand on these two trends and talk about what Intel has been doing with the open source community, with the industry, to derive value from the trends. So first, let's look at the trend. The shift from big data to fast data. In the past decade, many companies turned to big data analytics or AI applications to drive digital transformation and improve business results. In the past few years, they started shifting from big data, where analytics and learning are processed after the fact, to fast data. Fast data is data in motion. It provides the capability to learn continuously, make decisions, and take actions as fast as data arrives, typically in milliseconds. Just imagine, for a credit card company, when a user swipes the card, fast data analytics or AI applications need to immediately process hundreds of input variables, such as time, location, previous transactions, to determine whether to approve this transaction, all within milliseconds. For online retailer, fast data applications need to real-timely analyze a customer's shopping behavior, make more relevant product recommendations, and maximize the customer's purchase potential. For autonomous driving, fast data applications need to real-timely compute a vehicle's position, speed, direction, recognize traffic signals, pedestrians, and objects on the road to support safe driving. Implementing this fast data analytics or AI applications requires model training for continuous learning, which is computation and memory intensive. Many learning algorithms need to iterate a computation over a huge training data set and update a large number of model parameters until the model converges. To accelerate the training performance, it is very common to cache the parameters and the data set into memory, while memory constraint has been a constant challenge. So in the past few years, we have worked with many customers and helped them to work around the memory constraint, and we felt their pain. And this is why we recently announced Intel Optane persistent memory. Intel Optane persistent memory is based on the 3D crosspoint technology. Unlike traditional DRAM, it combines the speed of traditional memory with capacity and persistence of storage. It provides unprecedented high capacity, persistence, and affordability. It is available up to 512 GB per module and can extend system memory by more than 3 TB per CPU socket. So not only the hardware, we also deliver fully optimized software stack on top of it, from optimized operating system, virtualization, driver software, runtime, to optimized data platforms. Now customers and developers can leverage the new memory technology and address the challenges discussed earlier. So for instance, Spark SQL using persistent memory can have 8 times performance gain for decision support workloads. Apache Cassandra can have 11 times throughput, or 9 times throughput, and 11 times users over PCIe SSD. And for SAP HANA, with 6 TB data, a server with DRAM only requires 15 minutes to restart, while a server with DRAM and persistent memory can restart in 4 minutes. So Intel Optane persistent memory generated a lot of excitement among our customers and partners. Working together, we're creating and extending new generation of data center applications. And we have already started revenue shipment for select customers. It will have broad availability next year. Now let's talk about AI. AI is fastly evolving in the past few years. It has moved from lab exercise to solving real business needs. And we're seeing an increasing number of AI applications in use. So for instance, it's helping online retailers to analyze its customers' shopping behavior, make more personalized product recommendations, and drive up sales for retail. It's helping financial services industry to uncover frauds and anomalies more timely and accurately. It's helping healthcare providers to do automatic diagnosis and improve population health and reduce hospital costs. It's also helping to better predict weather conditions and reroute supply chains for optimal result. There are many more use cases for AI, such as autonomous driving, smart transportation, smart homes, smart cities, and more. There has been a debate for a long time whether it is more important to improve AI with algorithms or it is more important to improve AI with data. Given that you have a reasonable algorithm, data then is more important, especially more data and good data. The first example is ImageNet. We all know in the past few years, there was fast advancement with computer vision and image analysis. That advancement greatly benefited from the appearance of large public data sets like ImageNet. So in this case, big data set like ImageNet really pushed advancement of image analysis and computer vision. Another example is Google. Google is getting into the medical field, and especially doing automatic diagnosis for pathological, radiological, and microscopical images. Google already has good algorithms. What they're missing is good clinical data. And this is why, in past few years, Google spent a tremendous amount of effort negotiating with medical centers, healthcare providers, trying to have access to their clinical data. This also explains why we're seeing a tighter and tighter integration of big data analytics and AI. Combining the two, we can solve much more complex problems. And Apache Spark has proven to be one most effective platform that can unify AI and data analytics solutions. To make it easy to develop integrated AI and big data analytics systems, we have created an open-source BigDL and analytics zoo. BigDL is a deep learning framework organically built on Apache Spark. It has implemented more than 200 layers of neural network. It has feature parity with Caffe, TensorFlow, Torch, and other popular deep learning frameworks. It works seamlessly with distributed data and drives Hadoop and Spark as the unified data analytics and AI platform, giving customers the consistent and integrated experience from data ingest to data storage, data management, feature engineering, traditional machine learning, deep learning training, deep learning inference, the entire pipeline. It also reduces the total cost of ownership. Previously, customers have to stand up a separate infrastructure just for deep learning model training. And after the model is trained, and customers have to bring the trained model back to its existing data analytics solution stack and use the trained model to derive insights from the data. Now all that can be saved. You can do model training, model inference, model integration with the existing data analytics solution stack from the same infrastructure and reduce the total cost of ownership. So as of now, BigDL has already been adopted by almost all the top cloud service providers, such as Amazon, Google, Microsoft, Alibaba, Baidu, Huawei Cloud. And top ISPs like Cloudera and Databricks have integrated BigDL into their products. We also have helped many customers to build integrated analytics and deep learning solutions using Spark and BigDL on Intel. Now, Analytics Zoo is a new project that we open sourced. It makes it even easier to build the integrated big data analytics and AI pipeline. It unites Spark, TensorFlow, Keras, and BigDL programs into one pipeline. The entire pipeline can transparently scale out on the Spark and Hadoop cluster for distributed training and inference. And Kuka, Media, Cray, WordBank are the early adopters of Analytics Zoo. We do recognize that AI is no longer limited to data center. You can do the base model training in data center. You can deploy the base model to edge devices for timely inference. You can even do incremental training on the edge side to the base models. So there is a diversified need for AI. No single hardware technology can meet the diversified need. So we're seeing an emerging, comprehensive AI product portfolio. Intel is committed to game-changing and comprehensive AI product portfolio, driving up our performance, cost effectiveness, density, and programmability. At the hardware level, we deliver a wide range of technologies, from general purpose to targeted silicon, such as Ziya, FPGA, Nirvana, Mobileye, Movidius, Atom. And at the software level, we deliver fully optimized software stack to accelerate AI development and deployment. From libraries, frameworks, to tools and solutions. So for instance, we deliver Intel-optimized map kernel library, data acceleration library, and Intel-optimized TensorFlow, Intel-optimized MXNet, Intel-optimized Cafe, and deep learning SDK and deep learning toolkit. In the past few years, we helped many customers to build AI solutions or integrated AI and big data analytics solutions on Intel platform. We have worked with customers from cloud segment and from vertical segment, such as manufacturing, energy, healthcare, financial services industry, retail, and more. So I can share a couple of examples. The first example is our collaboration with JD.com. We all know JD is a top online retailer. We help this customer to streamline its feature extraction and image detection pipeline. And we brought 3.8 times performance gain for the end-to-end data analytics and deep learning pipeline versus running the same pipeline on GPU. In this case, the entire pipeline does not just include the training portion. It includes data ingest, data storage, data management, feature engineering, deep learning training, and deep learning inference. As a result, the customer migrated its solution from GPU to Intel. And today, the solution is running in production, supporting its graph similarity check system, IP protection system, and price monitoring system. Another example is our collaboration with financial services industry. Many financial services customers were seeing the fraud risks increasing tremendously in the last few years with the wide range of products, services, and customer interaction channels they have. So we help these customers to build end-to-end deep learning and data analytics pipeline and significantly improved their fraud detection rates. And I can go on and talk more about the use cases that we have done for our customers. So we have discussed the two exciting trends for the data-centric world. Data is shifting from big data to fast data for real-time insights. And AI and big data are getting more closely integrated for solving much more complex problems. And Intel has been working closely with the industry, with the open source community, to derive value from these trends and improve our life quality and improve our business results. And we look forward to continuing our close collaboration in the years to come. With that, thank you.
Thank you, Ziya. Thank you for your presentation, and thank you for all your effort in Intel and Apache community to make all those AI and deep learning projects possible. So at this time, I'd like to invite Brandon back up to present Ziya a token of appreciation. So please.